Hey there, professor, look what I brought. Now tell me what's my rock.
Okay, here we are. We're going to look at some rocks. I've got my new friend Steve here. Steve, he's got a whole bunch of rocks for us to look at today, and we're going to do our best to identify them.
All right.
Steve, first of all, what town do you live in?
I live in San Bernardino.
San Bernardino.
Devore.
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 Okay,
They
all
call
right.
it San Bernardino.
Yeah, but kind of up the hills,
Yeah.
up the way a little bit. Okay, good. So you're local.
Yeah.
All right. So why don't you go ahead and tell me about these rocks that you pulled out right here?
Okay. These are from the actual the meteorites that we're going to look at in a minute, but they're very interesting because they're paramagnetic
Okay.
and they won't retain heat.
Mm-hmm.
So I can put a torch on it and put my finger on it right away, and it won't retain any heat. So it's very interesting to me.
Okay.
And aside from that, the aqua regia,
Uh-huh.
it won't do anything to it.
Okay. Well, first of all, these are definitely chunks of metal. There's no question about that. This is something, it looks like some kind of a stainless steel. You've probably read about iron meteorites. Is that what you think you might have here? Is an iron meteorite? Okay. So where'd you find it?
Well, in the San Bernardino Mountains,
Okay.
up in the Cajon Pass area.
Okay. Was it near a road? Or did you hike in?
It was in the mountains.
In the mountains. Okay.
Yeah, hiked in, yeah.
Okay.
And see, the other one that's interesting...
Is that you found that in the same spot?
Yes.
Okay, why don't you go and let's go and pull that one out. This is one. Okay.
This is, really heavy.
Okay.
Really
very heavy. Definitely. So I can see there's chunks of metal in this right here. So this has got a lot of stuff going on here. First of all, there's a lot of brown, which suggests it's some rusted iron. It's pretty common color that we'd see, and makes sense because this looks like iron that's in here, and it's a whole big mess of all kinds of stuff in here. There's all kinds of other little chips of stuff that have bubbles in it that suggests that they've been melted.
I also have, I believe I have the footage of this landing.
Oh.
From the railroad.
Okay.
Okay. Now, here's the interesting thing. You know when we had the meteor scare?
Uh-huh.
And 2018?
I don't remember that. There was a meteor scare?
Oh, yeah. They notified everybody on the news saying there's a meteorite going to come close to the Earth, but may pass us by. It came in at the perfect angle.
Uh-huh.
And you could see it's headed right for the train. But it's up in the mountain range. And it used the mountain range as a ramp.
Okay.
Right? And hit the mountain range and slid down. And it was like molten lava.
Okay.
Right? So now...
And you have a picture of this?
Yes. I got another picture I have splats of this.
Okay.
Okay. That is like probably from here to the end of the table.
Okay.
Just one huge splat.
Okay.
I'll show you.
Okay. Yeah. Well, we can look at those in a second.
Very interesting.
Okay.
This is what was recovered. And I have the other ones in the car that are probably, they're very, very huge.
Okay.
Interesting. And I also had them tested, the metal.
Mm-hmm.
And it was iron and 30% nickel.
Okay.
And
Who tested them?
This was smelters in Palm Desert.
Palm Desert. Okay.
And she ran it for me and said, it's nickel. And I said, that's all I needed.
Okay.
Because I just wanted to know if there was nickel and iron together, because I know that's not in earth rocks,
Mm-hmm. So that is true that if you have iron with a substantial amount of nickel, that's not particularly common on Earth, except for in our core. This would not be from the core.
No.
We've never had samples from the core. Iron and nickel do like to play together. They like to be together. Their chemistry is very similar. That's why they're in iron meteorites together. So the first thing I want to do is I want to look at the composition of these. And I've got an instrument right here that we can do that with. We're going to look at the chemistry of it. We're going to look to see if there's iron and nickel in there. And I'm going to make a couple of more observations. Iron meteorites that I've seen are completely metallic. And this has a bunch of other things in it. We would call this heterogeneous. There's there's some material in there. This is with the little bubbles in it. That's not something I would expect to see in an iron meteorite. Iron meteorite can get little bits of stuff in it. Usually, it's a mineral called olivine. It's a green mineral for a meteorite that we call palisite, but that's definitely not what this is. So, the first thing I'm gonna do is I'm gonna put this on this machine right here. This actually looks kind of like a gun. It's called a X-ray fluorescence spectrometer. We just call it the XRF for short. And all it knows how to do is send X-rays into materials, and it'll tell us what elements are in there. So elements like iron and nickel, for example. There we go. Okay, so I'm going to start this. All right, so I'm definitely seeing a lot of iron. I'm seeing iron. I'm seeing very, very little nickel. So the way to read this is that this is parts per million. So there's a million parts, right? And so we're going to, in our head, add everything up to a million. So we've got aluminum, silicon, sulfur, calcium. These are all around 1,000 to 10,000 range, or thousands. But when we go to, let's go down to iron. See how iron is 855.1 K, 855,000. So that is about 86% of a million. So this is showing a composition of about 86% iron. Okay, and your nickel is right there, and that says 428. So that's 428 over a million. So that's going to be like 0.01% of this thing. So this is nowhere near the nickel that I'd like to see to suspect this for being an iron meteorite. So, okay. We can, if you want, we can do another couple zaps in other places. I have a feeling.
Maybe try another.
You want to try this
or
one?
This one here.
Try that one?
Yeah.
Okay. Let me make sure I'm on the spot. And we're going to start the analysis. And this one's got a little over 500,000 counts, so that's about 50%. So 500,000 is about 50% of a million. So that's about
of nickel
50% of iron. And nickel's coming through about pretty small too, about the same, like just a few hundred ppm.
The weight of it is exceptional. Iron is not that heavy.
Mm-hmm. Well, iron's this is a pretty dense material compared to other rocks. I mean, the reason it's dense is I think because it does have chunks of metal.
Yeah, this here is I mean, that's really heavy.
Yeah,
that's
I agree.
Really heavy.
I agree. Yeah, if it were a meteorite, we're usually, when a meteorite comes through space, it melts as it contacts with the atmosphere. You've seen this in movies, right? And so the exterior of it should appear like it was melted, like just the outside of it.
It does. The big ones do.
The big ones do.
Yes.
Okay.
They got the fusion crust.
So I don't see that here. So if this
because these were in the water, like by the like on the wash in the water type.
Mm-hmm.
So a lot of it's been.
So you think if there were a melted rind on it, that it's been weathered away and oxidized and destroyed by nature? Okay.
Yeah, definitely. Definitely, because it's actually in the water.
Yeah, okay.
Now, the ones outside are intact, haven't been broke. They got the W on the back. It reminds me of the Pac-Man ghost, right?
Mm-hmm, mm-hmm.
And it's got all the fusion crust, all smooth like leather.
Uh-huh. When did you take a picture of the meteorite coming down?
In 2018, you couldn't.
2018.
Yeah.
So that's 5 years ago. Nature is not going to be able to completely oxidize and sort of destroy the rind, even if it's underwater. I don't think after 5 years it's going to have that much. Maybe in a tropical ocean you could get some, but I think you would need hundreds of years, maybe thousands of years to go from a rind where there's absolutely no evidence whatsoever of a rind to explain that by have it sitting underwater for 5 years. So I think you would still see some rind after that, even if it were in water. Okay, so what do you got here?
I got this up to 3,300 degrees and still would not melt.
Okay.
It just created.
How do you know that you were at 3,300 degrees?
I have a gold melting furnace.
Okay.
Yeah.
So you put the gold melting furnace at 330 Fahrenheit.
Yeah.
Right. Okay.
And it won't do nothing.
Okay.
But this is, I believe this is one of the ones that tested for 30% nickel, and this one too. This
tested for 30% nickel?
I believe so.
Okay, so let's go ahead and...
I believe.
All right, so let's go ahead and zap this one. Dylan, you out of the way?
Yep.
Okay, good. All right, start. So we're getting 78% iron and 0.001% nickel. So a very, very small amount of nickel in this one too. So nowhere near what I'd want to see for it to be an iron meteorite.
explain though the paramagnetism that I can't get over. There's got to be an explanation.
So what I would say is that regardless of the magnetic properties of it, it doesn't. The fact that there's not a lot of nickel in it, I mean, that almost immediately completely rules out that it would be an iron meteorite. Let me just give you my summary of what's going on. So there's not enough nickel in any. We've done 3 analyses already, and none of them have very much nickel at all. They have a trace amount of nickel. So that to me is not going to be a natural iron meteorite. The second thing is that I don't see any evidence of a rind in any of the samples you have here, and there could be in other samples.
In the car,
you can check those out, but I don't see any evidence of a rind. I'm not convinced that if there was a rind on this, that it would have disappeared in 5.
Is that a rind?
This would not be. When I say a rind, I mean
this here.
I mean like it looks melted, like and it also has these little it has these little impressions that almost look like someone put their thumb in it.
Yes.
Right. The whole thing looks, and it looks like it was.
You'll see it.
The whole thing has been melted. Okay, but it's going to look smooth. Okay.
Yeah.
And this is not smooth. This to me looks like an oxidized surface. Also, another thing is that iron meteorites are typically not going to have this extra stuff in here that looks like this.
But what if it made impact?
We have a word for that called an impact breccia. A breccia is a rock that's been broken up and glued back together. And so you're proposing, therefore, that this would be some sort of
because you see
an impact and broken up.
Yeah, you see the stuff in between.
Right. I don't think that iron. So the thing about an iron meteorite, it doesn't really have the property where it's going to break up. It's not what we call particularly friable. So we're not going to get chunks of iron flying off and breaking up into the surrounding material like this that I'm aware of.
This was by the site as well.
Okay, let me see.
That's a splat. There's no other explanation for that to be there, because how far it is up in the hills, there's no way for a truck to even get up there to pour that.
It's hard for me to tell exactly what this is. This could be.
It's metal, just like this.
The whole thing is metal.
Yeah, okay. And it's got the little nickel peeking out everywhere.
Well, I mean,
or the little, shining.
Sure, but if it came from this, there's no nickel in any of these samples that I've found, so I don't think there's any nickel in that sample.
I got 30% nickel.
Okay.
On one of my little samples, and I probably just don't have it with me, but
okay, that's fine. That could be. I'm just basing what Also, if it broke up as a bunch of bits, the stuff that it is mixed with doesn't look like natural material. It looks like stuff that's been. This doesn't look like natural material. Now, maybe it was melted by the impact of the meteor. But here's the biggest issue. I haven't even gotten to it yet. Is that we have a common explanation for what this is, which is we call it slag from somebody's.
Okay, now that's interesting.
Somebody was out there they had iron ore. I don't know what it was. Maybe they had could have been a mineral called hematite. It could have been a vein of some iron-rich material. And what they do is you add stuff to it. And people, it's kind of like alchemy. Oh, it's not the right word. It's just sort of like it's like backwoods chemistry. It's like making moonshine. People will take what's available, and what you do is you put it on. The thing about iron is that iron in natural rocks is oxidized, and so we need to remove the oxygen. The way you do that is you make a big pile of stuff. You usually put charcoal in there, and the charcoal will remove, by burning the charcoal, that will help remove the oxygen from the iron and turn it into metal. And so that whole process is very messy. And a lot of times it fails. And I think all over the desert and all over Southern California, there are these little pockets of sort of old iron smelting operations. Maybe they were successful for a while, but they often will just leave their waste behind. And then people find it, and they think they may have found a meteorite because they make chunks of metal like this. So it looks like it might be an iron meteorite, but this whole thing can be explained by it being
not a blob that size. And the other thing is that this won't scratch a ceramic or porcelain tile.
Mm-hmm.
It won't make a mark.
Mm-hmm.
They say if it don't make a mark, it is definitely extraterrestrial. It's a meteorite. And the no retaining heat.
Mm-hmm.
And if this was just iron, it would have dissolved in the acid, nitric acid, or sulfuric acid for 2 weeks. This would have been gone. And it's not.
I mean, it depends on the temperature and the concentration of your acid. It depends. There's a lot of factors.
Straight sulfuric acid.
There's a lot of factors that are involved in that.
Yeah.
So, and I'm not. I mean, I could be. I'm not here to.
I'm just trying to share with you.
I'm giving you my opinion. I can't. I've done a lot of stuff with acids in the lab, But I've never recreated what you said that you did, so I'm not gonna dispute any of that.
Yeah.
I'm just saying that based on what I see here, this to me looks like slag that someone from somebody's iron smelting.
Okay. The San Bernardino Wash meteorite, right where this was found. If you want to take a look at that, it's just about identical.
Okay, sure. So let's go look at. Well, I've never even heard of the San Bernardino Wash meteorite, so I'm gonna Google that. I'm about to learn something here.
Yeah, because I can't ignore the fact of the paramagnetism, and I can't ignore the fact of not retaining heat.
So I don't. Yeah, let's just do this one thing.
Yeah.
Okay, what is Bob's findings? I mean, I see it's on the internet, but this is Bob's findings. So I need to find.
It's on the meteorological thing.
Don't. This is
See that there?
meteorite
You
times.
see that?
Yeah, I know, but I'm not.
That's identical to what I have.
I agree, but I'm not persuaded that this is still. That this is a meteorite. This is some. I'm looking for a professional resource here. Entry for San Bernardino Wash. They're chondrites, which means they're not iron meteorites. Proved by Alan Rubin at UCLA, a very famous meteoriticist. He's got 2 of them that he found that have been described.
They're just like this.
Well, this is a 1 centimeter one here, so this is going to be a really small chunk.
Mm-hmm.
But I do agree. These pictures look.
And the properties, the paramagnetism, man, that's got me so stumped.
I wouldn't get stuck on the paramagnetism because so an iron meteorite must be magnetic.
Mm-hmm.
But that's not the only thing that we would use. There are many other parameters. So I'm a little stumped because these pictures they're much smaller though. That's the thing, and I can see there are these things called chondrules. Chondrules are these little circular things.
Wait till you see this outside.
I'm
glad you're stumped. I'm glad you're because I thought I was going crazy.
I still this one doesn't look this looks like slag to me.
But remember, it's exceptional.
Just hold on. So these are small samples, and they have these little chondrules in it. Remember the scale of these this is 1 centimeter, so they're going to have these little tiny sand grain sized chondrules that are going to be in it. And so that's why they're calling this a chondrite. They do look similar to what you have. And, I mean, I understand why you would say that. And
like this here, I think that's a piece of fusion crust here.
That to me is just. I mean, first of all, other thing about these is none of these have a fusion crust at all. There's no fusion crust on any of these samples here. So these look like they've been sitting out, as you say, they've been sort of weathering.
Yeah, same with these. But when you see the ones out in the car, you're gonna really be stumped. Promise you, they got the full skin, everything on them.
So the other thing is that these things, the location of these presumably would be pretty good match to where you found it. Exactly the same. Okay, so but
maybe
these guys have been out there looking for stuff, and so we have to also explain why they were able. How come they overlooked what?
I can explain that.
What? How?
Okay, because the big splat is in the wash. And it was very. We had to uncover it with other rocks.
Mm-hmm.
The other thing is that since the rain started,
mm-hmm.
it had done some erratic erosion in the ground.
Mm-hmm.
We're talking 4 feet down,
mm-hmm.
a crater 4 feet down, 6 feet across, 25 feet long,
mm-hmm.
where we have to drive around it, right?
Mm-hmm.
So, and I looked in there and it looked like a bunch of the stuff. So I grabbed one and it about tipped me in there because
mm-hmm.
it was really heavy. This
mm-hmm.
thing was about this big,
mm-hmm.
and so. The fact that these are showing low nickel count, I don't know if it could be maybe other concentrations get in the way, or maybe this exact little piece just doesn't have that much nickel in it, or
mm-hmm.
I don't know, but I know the chemical reaction I get
mm-hmm.
from the acids
mm-hmm.
indicate rhodium.
Okay, so I'm skeptical about that because rhodium is it's actually one of the most expensive elements.
Yes.
It's extremely rare. So,
But it's the only thing
I don't think I don't think that just because something turns red in acid is definitely definitive of there being rhodium in it.
Well,
I'm
they
skeptical about that.
Yeah, well, they gave a definite answer on Google about it.
Okay.
About the colors of the reactions you get from the colors and what it would be.
Mm-hmm.
You know,
Mm-hmm.
there's like 6 different colors.
Okay. Well, let's go have a look at the one I.
Yeah.
So remember, the picture you showed me was a 1 centimeter piece with these tiny chondrules in it that are really tiny round grains that formed during the early solar system. I'm not seeing these little chunks here are not little round grains. These are they're a little porous. Looks like they have some holes in them from gases. I can see why you would think this is like some sort of an impact feature, right? It hit and it made a bunch of chunks, but I'm not even seeing them. Where's the metal in here?
Enormous. This is all metal.
This is
The black one.
This
Yeah.
isn't metal right here.
Metal.
This is metal, but this is not metal.
No, this.
This is not metal. I'm showing you this piece right here, this black piece.
Yeah.
That's not a metal. This is more of a porous material that was used. So this, I believe this is the metal because you can see that it's been oxidized. But this is a mixture. These two things are different. This black stuff right here is not the same thing as that. We didn't bring our file out here though, huh? So let's look on the side here. So you've got this. This looks like, yeah. See down here, there's all these holes in here.
That's been in the water though.
So this part up here has been above the water,
Right.
and this part was sitting in the water.
Yeah.
Okay. Should have brought the.
See, I sliced it, and here's all the steel in there. And then that's where I broke the rest of it off. I just broke it off.
Mm-hmm. Okay, there's the steel right there. Yeah, see, these are big chunks. These are bigger chunks. I mean, the only crust here I see is a little bit of an oxidation crust, which is the brown from the iron that's been oxidized.
So then what's this?
That's just this is a chunk.
Uh-huh.
This material, this big rock, is a bunch of rocks that have been glued together. So there's a gray stuff here, which we would call a matrix, which is sort of like a glue that's gluing these chunks of black together. Some of the black chunks have been oxidized.
It's been melted together. This is all melting stuff.
Sure, which would happen during a slag process. I don't know that this
Slag cannot be that big up there. There can't be that much slag. What could possibly create that much slag? Explain to me what could possibly create as much slag as a city bus.
As a city bus.
Yes.
Well, there could have been an ore deposit up there, right?
An ore deposit?
Yeah, I don't know what the geology is. We have to find out where it is.
An ore deposit.
Like a iron, like a chunk of. I mean,
that spills like that.
That's why the slag is up there,
I have
because
the impact video.
it's.
If that's not going to do it, then I think I'm in the wrong place.
That's fine.
Because UCLA would agree with me, and I'm going to make an appointment with him and go see him because I left him my name and number.
Okay.
And he left me a message. So there's nothing that can create this much slag at one time. There's no smelter, nothing that can create this much slag at one time. I don't care what you smelt, but to pour out the size of the city bus, that's insane. And to have the blue in it like that, that's insane. And my piece that tested 30% nickel, I can't, you know what I mean? This is definitely meteorite stuff because where I got the 30% nickel is from a piece by this one.
Mm-hmm.
So I'm gonna tell you my sort of final analysis of what's going on here, and then I want you to have the last word, and you can say everything that's on your mind because you're very enthusiastic about this, and I appreciate that.
Yeah, I've done a lot of research.
You've done a lot of research. I've also done a lot of research on rocks, so I do. I pay my mortgage doing this stuff.
Yeah.
First thing I want you to know is as a scientist, I don't claim to know everything. I'm perfectly willing to be wrong, and that's not. I have no ego in this. You've come to me for an opinion. I'll give you an opinion. The number one observation here is that the iron doesn't have any nickel in it. The ones that you show me. So,
well, they do.
I welcome. Well, they don't have nearly enough.
That's
nickel.
not 5%.
Not even close to being 5%.
Okay.
We're talking the fraction of a percent of nickel. Nowhere near close. Now, there's two types of iron metals that are meteorites. One is
Mhm.
called camosite. The one is called taenite. Taenite is the nickel-rich one. Camosite is the nickel-poor
Lower,
one.
yeah.
It's possible that there is a meteorite out there that has pretty close to pure iron. So I'm going to go confirm that. I think the probability that's pretty low, but I will confirm that, because the reason is because even though there's no nickel in the metal, the picture you showed me looks very similar to what you have, and that was on from the Meteoritic Society, which is a very reputable organization of scientists. And the reason we say that's reputable, by the way, is because these are scientists that are experts in the field, but more importantly, science goes through a process of internal peer review, which means that scientists try to criticize things, and they think if they look at things critically. And if something's been published in the Meteoritics, then that's gone through that process. So I'm more willing to trust what's going on there. So I'm going to look into that sample, the San Bernardino wash meteorite, a little bit more, so that I understand exactly what it is. One thing is that remember that the picture is a very small sample and has these little things called chondrules, which are these little spherical droplets that are they're bigger than a grain of sand. It's not obvious to me those are in this sample. There are droplets in here, but these droplets are metal. They're round little bits of metal in here. They're not made of the things that chondrules are made of, which are typically made of things that are like aluminum silicate materials and magnesium things. Doesn't have the same composition as that thing.
It's been an acid. Remember that.
Sure.
A lot of it ate off.
That's fine, but I mean, I can take this right now, and these little things, I can file it off, and I can expose. I can see that I'm exposing the iron metal in these little droplets here. So these little bits are iron droplets, not a silicate material, which is what I want to see for a chondrule. But I'm gonna go a little bit.
Does this have chondrules?
I don't see any droplets in there like this to me doesn't. This one doesn't look like the picture at all. This to me really looks like slag. So of all the things you show me today, this is the one I'm pretty sure this is slag. But I'm willing to
shoot this one with your gun.
Sure. I think the thing in your car, those little chunks in it, they look like.
It's so shiny metal though.
Well, but that's what we would expect in a slag. So, so the question is, if that is slag, maybe it isn't slag, but it looks like something it looks like, I don't know what it is. So let's be clear. Like,
it's not
people are out.
Metal.
People are out in the desert doing all kinds of weird things.
The
I don't
iron
know what
does
they're doing.
not shine like that.
Sure, it does.
Iron does not shine like that. This is a very unique metal. The nickel, it doesn't.
Steve, we just tested that, and that's almost pure iron. So. If all you brought me was this, I would say this is definitely slag, because this has the remnants of whatever.
Okay, but if that was regular iron, it would get hot when you put a torch to it.
So I'm not really sure. You've mentioned that a few times
because it's very important. It's very important.
Well, but I want you to send me the resource of how you say that's important, because I'm not really. I haven't seen that.
Any piece of metal, brother. If you put a torch on any metal, it's going to heat up.
Sure.
Correct.
I would agree to that. So if you're saying if I put that on a stove,
if you put a torch, MAP gas torch.
But if we put this on a burner, if I put this on a hot plate right now, we could run this test right now.
We could do it right now.
We'll put this on a hot plate, and this is not going to get hot.
Nope. Here. Nope. I promise you. Here,
you got a hot plate in here, Dylan?
Bigger piece. There you go.
Okay. All right. So let's get this going right now, because it'll take a little time. And I'm going to put it on the highest setting.
Highest setting.
You did welding, and that's pretty hot.
Yeah, I use MAP gas. So
yeah, that's the real deal.
Yeah.
Okay.
You could pick this right up off of there whenever you want.
We'll put them all on there.
Yep.
I'll put it right in the middle.
Okay, I have it on the max. Do you want?
Let's max it out.
Max it out.
So we might have to give it a little bit of time.
Yeah,
so that's fine.
You give it all day.
Okay,
you can pick it right up off.
Okay. While we're letting that heat up, and that's on 10, we'll do a XRF analysis on this one last bit here. Where would you like to analyze? Want to do it on that spot right there?
Metals, yeah.
Okay. I can smell the hot plate turning on right now.
Mm-hmm.
And I'm going to zap that right there. 800,000 iron. So that's 80%, 81% iron. And nickel isn't even showing up on this analysis. There's a nickel right there, 1 million. So I think there's so little nickel in there that we're almost at the limit.
I have one at 30%.
We're almost at the little.
I have one at 30%.
Okay.
So I do have.
Let's bring that in and let's see what.
You don't have to worry about it being hot. It's not going to get hot.
pan really
Ooh,
efficiently.
that's pretty hot.
That one's pretty hot.
Yeah.
Okay. What about
How
that?
hot does that plate get?
It's gonna be hot. I mean, it's not gonna melt that. It's probably, I don't know. It's probably like a pizza oven.
Yeah, it's pretty hot.
Can you pick that one up?
I could pick it up, but
But it's warm. Okay,
it's
so
pretty hot.
it'll be hotter than that.
I mean, but that plate is hot. The white
Yeah.
is really
I don't
hot.
think it's as hot as map gas though. So a map gas is probably really. I mean, we're not gonna melt iron on that hot plate. I don't believe.
No.
So
Yeah, they're getting pretty hot.
it's
I have
hard.
the impact video, bro.
Okay, well, let's have a look at the impact video.
Just look up meteorite that hits Cajon Pass 2018.
Okay.
Now you'll see it hit the mountain and skip right down it. Now look down here. Bam, see it hit the mountain?
Okay. But
And it left that trail on the mountain?
okay, but first of all, what I'm seeing here is I'm
Right.
seeing the Cajon Pass. Looks like it's winter time.
That's a train.
Oh, it's a train. Okay, so
Yeah.
this is the Cajon Pass.
It's like right in the middle of the pass.
So, but you're proposing that this is the meteorite that hit the ground?
It did hit the ground.
Okay, so I see that, but you're proposing that that's what this
Yes,
meteorite
'cause
is.
that's right where I found it. And the splatter zone goes up into the wash. And those droplets are part of the splatter zone.
I want to confirm that. I mean, this is somebody on YouTube, and I mean,
But
if-
I went
if-
to the location and found it. And you got
Have
San
you-
Bernardino
have-
Mountain,
okay.
San Bernardino Wash meteorite.
right,
that is
okay,
identical
I
to
want to have
that.
to see that. So,
You know what I mean? I don't see what
but the San Bernardino,
it has the blue stuff in it and everything.
When was the San Bernardino Wash discovered? Let's go look at that. So the San Bernardino Wash one, it was found in 2010. So that would be 8 years before this meteorite hit.
Okay.
So the timing is a little inconsistent there too.
Yeah.
So that's not as persuasive to me. That video, anyways. If this is
Well,
San-
I'm not sure this is from his stuff either. This could be from the 2018. That's right where I found it.
Sure, that could be.
You know,
but
but-
if that's the case and it's not the San Bernardino Wash one, and the picture you showed me is going to be less useful in trying to figure out what that is.
Is this where you ultimately get meteorites authenticated? Is that a university?
So I don't, to be honest, I don't know what authentication means, in a sense that I don't know if is there an organization that gives you a certificate? Probably.
Yeah, you got
There
it.
might be some specific institutions that do that.
Yeah,
I don't write certificates. We just look at rocks and I give you an opinion. So I mean, if I thought something really was a meteorite, I would write something up, and I guess I could say, in my opinion, this is a meteorite because of A, B, C, D. I'm not prepared to do that at this point.
Yeah.
For this kind of thing. So, I mean, people could reasonably trust my opinion, I suppose, because I have a publication record and I have a PhD and I teach rocks and stuff like that.
Rocks,
I'm a professor.
Are you a
A
professor of
meteorite.
meteorites?
I'm not a professor of meteorites, but
Okay.
I am a professor of rocks, and a
Yeah,
meteorite
right.
is a rock. So
And
I
went
know
to-
I understand what to look for in the meteorites, and sometimes you're the first person that's come in here that picture has given me a little bit of pause, which is why I want to look into it a little more. That's nothing unusual. It just means
the
I'm not-
weight, the paramagnetism, man. It's just
I mean, I know I'm not giving you the reaction you'd hope for. I think you wanted
no,
more
because I just don't
enthusiastic
think it's a
identification.
thorough. I just kind of think you're just kind of like, okay, this I don't think it is because of this. But
Going there.
if you look up, can you identify properties in a meteorite with an XRF? It'll tell you no. You need to do a chemical analysis because of the mixture. So many mixtures that it
I don't know where you got that, but I know that XRF can detect iron and nickel very, very
does
well.
iron have aluminum in it?
Iron and aluminum are two different things. So that's like saying,
But why does this have aluminum?
why does this have aluminum? In my opinion, it's probably slag,
Mm.
and there's other materials they mix in with iron ore. It could have been from the original iron ore. It could have been any number of reasons that there could be aluminum. There's nothing unusual about that being in there.
It says meteorites have it in them.
Correct. Meteorites do have aluminum in it. So
there's not
in
enough
fact,
no's here to say that it's not.
Chondrules have aluminum in them. Okay?
So there's not enough here to say that it's not because there's some yeses that it could be because
You are correct. I'm not going to say 100% that this is not a meteorite, but I'm going to put it at a 98% probably not a meteorite. Let's put it like
with
that.
no chemical analysis.
Well, we just did a chemical analysis. There's no nickel in it.
That's not chemical.
This is chemical. That's what the purpose. We're analyzing the chemistry. We're analyzing.
That's an X-ray, right?
Yeah, but the purpose of it is to analyze the chemistry
Right,
of the
but
material.
it won't-
It uses X-rays.
It
In
won't
fact,
detect
this is
meteorite stuff. I promise you. Look it up. It won't detect meteorite. You can't use an XRF on a meteorite. It won't give you an accurate detection.
it is correct for certain elements. They're going to be below detection, and it's going to be hard to detect them. But for iron and nickel, it's very good at detecting them.
Okay.
All right, but let's just leave it at that for now. I'll go look up a couple things. Again, I'm gonna put it at 98% or higher that this is a slag pile. But I'm gonna leave open the idea that I could be wrong.
There is a
wrong
whole
many
city
times.
bus of slag there. Then I don't know where that came from.
That-
but I tell you what,
that's
whoever
a-
was smelting was really smelting, bro. Because
I believe it.
no, that's
I
not
believe
possible.
I believe it. All right, we got to wrap it up.
All right.
But this has been fun. This has been interesting today, and I love your enthusiasm. Thank you so
I'm not
much.
gonna quit.
Thank you so much for coming in.
Yeah.
And we'll look at it a little bit more. I think it's still slag, but we'll
Slag does not look it up.
Okay.
Slag does not carry steel like this, bro.
It
At
sure
large
does.
amounts of
I've
steel. Does
seen it.
not.
I've seen it many times, so that's okay. We can disagree. I don't mind at all. Okay, well,
Yeah.
Steve had a lot to say, didn't he?
Yeah. That was, you made a good observation. He's very passionate about it. And
Yeah,
I've had students like that.
it's cool.
Yeah. It's really showing like what we scientists do in a way, because
Right.
like we don't just take people's observations at face value. We need to have it demonstrated in front of us. And
Correct.
so
Well, that's why I think people, if there's one thing I could share with the world about science, is that the essence of science is doubt.
Mhm.
And scientists, our instinct is just to pick stuff apart. And when if someone comes in and they say, I read this online, we're like, well, where did you read it? And it's not, we're not being jerks. It's just we do that to each other.
yeah.
That's what it's called, peer review.
Yeah.
And we're like, where did you find that? So
So
but oh my gosh, yeah. So that was the most interesting one we've had so far, I gotta say. And it all turned when I saw the picture on the website, which at first I was like, what? This is some guy out in the desert.
Mhm.
But then it linked to the Meteoritic Society.
I still want to see that one in person to see what's going on, but
I do too. But it had chondrules in it. You could see the chondrules. The chondrules are these little spherical balls.
yeah.
But that's one thing I want to go research is what is the range and size of chondrules? I don't know that off the top of my head. Do you know?
Not off the top of my
I don't
head.
think they get very big. So
No.
and also I want to know how often do you get metallic iron and nickel in an L5 chondrite, which that's what it was classified as, and what is the composition of the metal? Is it possible that you can get iron-rich metal in an ordinary L5 chondrite? I don't know the answer to that. It's possible. That's why I said 98%, because there's a few things batting around in my head.
Yeah.
I'm like, I've never claimed to be a meteorite expert. I know something about rocks, I guess, but there's always something to learn. And, I'm just trying to leave open those little windows for, I don't know, maybe it is a meteorite. God damn it. Probably isn't. What do you think it is, Dylan?
If I'm putting money down, tell Vegas that I'm putting it down on slag.
Yeah, no question.
But another thing that I saw that made me kind of skeptical was his video that he showed.
Yeah.
You look at the speed at which that thing was falling,
Yeah.
and meteorites on that scale, they should be going through the frame really fast.
It should be instantaneous. That's a good point.
So I'm like, yeah, that doesn't seem like that would be a meteorite in my book, but
yeah, that's a really good point. In fact, is it blazing at that point, or is it just a rock hurtling through space? Is it on fire when it's that close to Earth? I don't know.
Yeah, well, I know it would be glowing in the upper atmosphere, but usually by the time it gets down to the lower atmosphere, it's slowed down enough it doesn't have as much friction.
But he's excited about his video.
He is.
And he's excited about the place. And his point was like, well, if this is slag, this is the size of a bus. And I'm like, yeah, okay. But people are weird. They do weird stuff out there. You know what I mean? I don't know what they're doing out in the desert. Maybe it's not slag. I don't know. It could be I don't know. What do you think it is if it's not slag?
Yeah. I mean, if it wasn't slag, meteorite would actually be like a little bit higher on the list, but it's just that's such a weird specimen. I wouldn't really think of it as being a meteorite. So,
well, I think it's either something human made, or it could be something eroded and there could be some kind of a cemented
Breccia.
breccia in the desert on the surface of a wash. I've seen these in Arizona.
Okay.
So it could be something like that. But then when you showed that picture, those little bits didn't seem natural at all. They looked like weird chunks of some kind of slag material. So I have no idea what.
I mean, it could be slag that has gone to the bottom of a wash and then got cemented
That's
in.
exactly. It could be multiple layers or something like that. But does it happen that fast? I don't know, because it's definitely not something it's got to happen in the past. Let's give it, at most 500 years, right?
Yeah.
Unless the indigenous people were out there making slag, maybe it's a fossilized indigenous slag pile, but I don't think they did stuff like that, right? I don't know.
Yeah.
That's why I say we should talk to a historian. Like, what do you think this is? There could be something, there's always something that happened. I was embarrassed. I couldn't remember the difference between paramagnetic and ferromagnetic. I was just like, I gotta go reread all that stuff and make sure I remember that, because that was a little embarrassing.
I won't lie. When he said that, I was like, okay, I'm behind the camera. I'm going to go quickly over to the computer and look it up myself just to make sure. I think I know what it is, but it's like.
There are several different types of magnetic susceptibilities, and they all have their own properties. They all have their own names. And in geology, we just put a magnet on something, and does it respond to a magnet? And we're only looking for specific things. It's almost always going to be magnetite, unless we have some rare alloy in a serpentinite or something, I guess, or a meteorite, right? And it's always just, is it magnetic? And he was going on and on about these particular properties, and I'm like, hold on, I'm not really sure. First of all, I'm using the words wrong. I'll just need to go review that. That's okay. Whatever. It's a good model. Students forget things sometimes, and we got to go read. Maybe I'll go to a library. Remember libraries?
All those ancient things.
All right, so I put it 98% probably slag. I frankly put it 99.9% slag, but I'm going to leave open the possibility I'm wrong on this one. What probability are you putting it at slag?
I was going to go higher, but there's not much higher. So just to give a different number, I'll say 98% myself.
We don't want to get asymptotic to the to 100%, something like that. We're in the limit. But we'll see. He was a fun guest. And we'll talk to him again, and I want him to bring. He kept talking about the 30% nickel. Let's let him bring that in. We'll see what we get.
Yeah, and see what the Niton says. Because, I mean, we got to compare against the same analysis in a way there, too. So
that's right. And maybe what we'll do is we'll bring in some stainless steel with nickel in it, and I'll show him what it looks like.
Yeah.
When we analyze something that we know that has nickel, and like a belt buckle. In fact, I learned I have a nickel allergy, ironically.
Oh, okay. Yeah.
And so I have an old belt buckle that has a nickel in it. So maybe we'll analyze the belt buckle so he can see what it looks like when nickel is present. And then we'll analyze his so he can see that there's no nickel. And maybe that'll persuade him. But I think it won't. He's just excited about his find. Yeah. And that's fine.
Yeah, he's excited. He is pretty deadlocked on it. It's like
it's okay.
Yeah.
That's okay. That's what's fun about it.
Yeah.
Alrighty. All right. Well, hope you enjoyed this episode, and we'll be seeing you next time. Thanks for watching.
Yeah, I've seen it all. That's why they call me a professional. I know you're proud of what you got, but this rock ain't worth diddly squat. I'm not saying that you'll never be wealthy, but this preoccupation doesn't seem healthy. Don't give up your day job, you better keep it a hobby on the weekend.